Welcome to the deep dive. Okay, so picture our solar system, right? Not just our quiet neighborhood, but like a bustling cosmic crossroads.
Yeah, a port of entry almost.
Exactly. And it seems like there's a steady flow of visitors, interstellar objects just passing through.
Objects kicked out from other star systems, probably nudged our way by gravitational jostling way out in the Oort cloud.
Like someone bumping a giant cosmic snow globe, sending these icy bits flying. And isn't our whole solar system heading towards Vega? I read that somewhere.
We are, yeah. Which apparently makes that a pretty common direction for these interstellar objects to approach from.
Interesting. So we think maybe thousands cross Neptune's orbit every year, but the first one we actually saw and confirmed was Oumuamua back in 2017.
That's the one. And it wasn't just that it came from another star. It was just plain weird. Its behavior, its movement.
Yeah.
It didn't quite follow the rules we expected.
Defied typical physics, you could say, which led to some pretty out there ideas.
It certainly did. Lots of head-scratching.
And that's what we're diving into today. We want to unpack what made Oumuamua so strange, the debates it sparked, and what we can learn from it and maybe others like it. So where did this cosmic scout first pop up?
It was October 19th, 2017. The Halikalo Observatory in Hawaii spotted it.
Right.
And initially they thought, okay, it's a comet. Gave it the designation C-2017-U1.
Standard procedure for a new fuzzy thing in the sky.
Pretty much. But then as they watched it, something was missing. The coma, that fuzzy halo of gas and dust you expect around a comet near the sun.
Wasn't there.
Nope. Completely absent. So they had to rethink. They reclassified it as an asteroid, A2017-U1, which was unusual for something moving like this.
A cosmic identity crisis right off the bat, from icy snowball to, well, space rock. But the interstellar part, that came from its path, right?
Absolutely. Its speed was just incredible. Way too fast to be trapped by the sun's gravity. Its trajectory was what we call hyperbolic.
Meaning it swings by the sun and just keeps going, one pass only.
Exactly. No return trip. That was the dead giveaway. It wasn't from around here. So it got its name, Oumuamua Hawaiian, for scout, or first distant messenger.
Fitting.
And it even prompted the International Astronomical Union to create a whole new category, I, for interstellar. So its official designation became 1I 2017 U1.
Wow, the first of its kind, literally naming the category. Okay, so it's an outsider. What else did we figure out in that short time we saw it? What did it look like?
Oh, look like is tricky. It was small, maybe a few hundred meters long, perhaps up to a kilometer at the very largest estimate. But the key thing was its brightness. It changed a lot.
Crusading.
Yeah, dramatically, over about a 7-hour period, which suggested it had a really extreme shape, either, super elongated like a cigar.
Or maybe really flat, like a pancake or a disc.
Exactly. And it wasn't just spinning neatly. It seemed to be tumbling end over end through space.
What a bizarre image. And if it was an asteroid, the rocky kind, that raises questions, doesn't it? Asteroids usually form closer in the warmer parts of a star system. How does one get flung out into interstellar space?
That's a puzzle. You'd probably need a pretty big gravitational kick, like a close flyby of a giant planet in its home system, to eject something rocky like that.
But what about the comet idea? Could it still have been an icy body just hiding it?
That was another possibility. Maybe it was a comet that had been traveling for so long, billions of years perhaps, that it built up a thick crust of dust.
Like insulation?
Kind of. Blocking the sun's heat, preventing the ices underneath from vaporizing and forming that visible coma. Sort of stealth comet, if you will.
A dust-cloaked comet. Okay, interesting. But the shape, the potential origin, those were weird, but they weren't the main thing that got everyone talking, were they? What was the really big mystery?
You're absolutely right. The truly baffling part was its movement. It zipped past the sun super fast, as expected.
Because of gravity, yeah.
Right. But as it moved away from the sun, it sped up just a tiny bit.
Yeah.
But it was definitely accelerating more than gravity alone could explain.
It got an extra push from somewhere.
Exactly. Its path just didn't quite match what our understanding of orbital mechanics predicted for an asteroid or even a typical comet. Something else was acting on it.
Okay, that's the kind of observation that really gets scientists buzzing. Thinking outside the box, maybe even, like you said, into some wild territory. So what were the initial attempts to explain this extra nudge?
Oh, they looked at the usual suspects. Solar wind pressure, the push from particles streaming off the sun.
Not strong enough.
Nope. Not nearly enough to push something Oumuamua's estimated size that much. Then naturally, they thought about comets again. Comets get a push from outgassing, right? Ice turns to gas, jets off, acts like a small rocket engine.
Makes a tail, gives it thrust. Makes sense.
But here's the kicker. telescopes,
Hmm?
including the Spitzer Space Telescope, which stared at it for like 30 hours in the infrared.
Found nothing.
Found absolutely nothing. No dust, no gas, no telltale heat signature you'd expect from outgassing. In fact, the lack of infrared suggested it might be surprisingly shiny, maybe even metallic, which again is weird for a typical comet.
Wow, Spitzer's silence is pretty loud there. No gas, no dust, just acceleration.
Okay, this feels like the point where the conversation shifted, didn't it, towards more, let's say, unconventional ideas.
It really did. And this is where you get one of the most talked about, maybe controversial hypotheses from Avi Loeb at Harvard.
Ah, yes, the alien technology angle.
He argued, look, solar radiation could provide that push, but only if Oumuamua was incredibly thin, like paper thin, less than a millimeter thick.
For something hundreds of meters long, that sounds unnatural.
That was exactly his point. He suggested it seemed highly unlikely for a natural object to have that kind of extreme aspect ratio, leading him to propose it might be artificial. A light sail, maybe, designed to be pushed by starlight. An alien probe sail tumbling through our solar system. That's definitely a bold idea. Captured the headlines for sure. But not everyone in the scientific community jumped on board, right?
Oh, definitely not. That's a very fair assessment. There was significant pushback. Darrell Seligman, who was at Cornell then, offered a more, well, natural alternative.
Okay, what was his idea?
He suggested maybe it was outgassing, but releasing something invisible, specifically hydrogen gas.
Hydrogen. Why wouldn't we see that?
It doesn't interact with light in the same way as dust or water vapor, so it wouldn't create a visible coma or tail. His initial thought was maybe Oumuamua was a chunk of frozen hydrogen, an actual hydrogen iceberg.
A hydrogen iceberg silently venting gas as it warmed up near the sun, providing that push. Still unusual, but maybe more plausible than alien tech for some.
It was definitely aiming for a natural explanation. But Loeb countered that pretty quickly.
Oh, what was his objection?
He basically did the math and argued that a pure hydrogen iceberg probably wouldn't survive the trip through interstellar space. Even the faint starlight out there would be enough to sublimate it, to boil it away, long before it ever reached us.
Right, hydrogen is super volatile, so that theory kind of fizzled out.
The pure hydrogen iceberg idea, yeah, it faced some serious challenges. But Seligman didn't totally abandon hydrogen. He teamed up with Jennifer Bergner at UC Berkeley.
And they refined the idea.
They did. They looked at lab experiments showing that water ice, when it forms in really cold, irradiated conditions like deep space, can trap molecular hydrogen inside its structure.
Like hydrogen molecules getting stuck within the water ice lattice.
Exactly. So when that ice gets warmed up even slightly, like Oumuamua passing near our sun, the ice structure can shift, relax a bit, and release that trapped hydrogen.
Ah, so it's not made of hydrogen, but it's carrying it.
Precisely. They called it a dark comet model. Mostly water ice, but it picked up trapped hydrogen on its long journey. The warming releases the hydrogen, providing the push, but because it's just hydrogen and the ice isn't breaking up into dust, you don't see a coma.
The dark comet. That sounds clever. It potentially explains the acceleration and the lack of visible stuff. Did that satisfy everyone? What did Loeb think?
He remained skeptical. He published more papers questioning the calculations, arguing the amount of hydrogen needed wouldn't be trapped efficiently enough or released correctly. He still leaned towards the artificial origin as being, in his view, less problematic. So the debate really continued.
Fascinating. A proper scientific disagreement playing out. But then the story took another twist, didn't it? People started looking for similar weird acceleration closer to home.
That's right. Seligman and others thought, okay, if this hydrogen release thing is real, maybe it happens to objects in our solar system too. So they went looking through data on near-Earth objects.
And they found some.
Amazingly, yes. They found about half a dozen small asteroids, just a few meters across some of them, right here in our neighborhood. Not interstellar, just regular asteroids.
But they were also accelerating mysteriously.
They showed tiny accelerations that couldn't be explained by gravity or solar wind, and they had no visible outgassing either. Very Oumuamua-like behavior, just on a smaller scale and, well, closer to home.
So Oumuamua might not be unique in its behavior, even if its origin was. That's really interesting. And isn't one of those local weird ones getting a visitor soon?
Yes. Asteroid 1998 KY26. It's on the itinerary for Japan's Hayabusa 2 probe, the one that visited Ryugu. It's scheduled to reach KY26 around 2031.
And KY26 is one of these objects with unexplained acceleration.
It is. It's also known to be water-rich and spinning really fast. So the hope is getting a close-up look might finally reveal what's giving it that extra push, maybe shedding light on Oumuamua indirectly.
Very cool. Studying our own oddballs to understand the interstellar ones. Now, Oumuamua wasn't the last interstellar visitor. We found another one, 2I Borisov.
Correct. Discovered in 2019. But Borisov was, well, much more normal as interstellar visitors go.
How so?
It looked and acted like a classic comet, big coma, long tail. Its composition wasn't wildly different from solar system comets. It behaved itself, gravitationally speaking. So, while definitely cool to see another visitor, it didn't deepen the Oumuamua mystery. It just showed interstellar comets exist and can look pretty familiar.
A more conventional tourist. And we know this traffic goes both ways, right? We eject stuff, maybe we capture stuff too.
Absolutely. We know of at least one comet, C1980E1, that got kicked out of our solar system by Jupiter and is now heading into interstellar space. And they're candidates for captured objects, too. Comets like Makos-1 or Hyakutake, maybe even some weird asteroids orbiting backwards, like Kai-Pyoka-Wela near Jupiter. Their chemistry or orbits hint they might have come from somewhere else.
So our solar system isn't totally isolated. But none of these other examples really explain Oumuamua's specific weirdness, especially that acceleration.
No, Oumuamua still stands apart because of that combination of characteristics, particularly the acceleration without outgassing.
And unfortunately, our chance to get more data on Oumuamua itself is long gone.
Yeah, sadly, it's incredibly far away now, billions of kilometers, and moving fast, about 26 kilometers every second. We only had eyes on it for a couple of months after it had already made its closest pass by the sun. The window was just too short.
Which leads to the big, maybe crazy idea, should we chase it? I know there's been talk like Project Lyra.
There has. Project Lyra looked into the feasibility. And the challenges are, well, immense. You need incredible speed to catch up. You need a way to slow down when you get there decades later. And you need to find this tiny thing in the vastness of space.
Sounds almost impossible. How would they even propose getting that kind of speed?
They sketched out a couple of options, mostly relying on gravity assists. One faster route involves using Jupiter and then doing a super close flyby of the sun, a solar oberth maneuver.
Using the sun's gravity like a massive slingshot.
Exactly. Get really close, fire your engines at maximum velocity, and fling yourself outwards at maybe 70 kilometers per second or more. Big problem there is the heat shield needed for that sun dive limits your payload. Plus, it's complex, unproven tech.
Okay, what's the other option?
A slower, maybe more achievable path. Multiple flybys, Venus, Earth, maybe another deep space burn, then Jupiter for a final boost. Slower arrival, maybe late 2040s if launched in the early 2030s, but easier deceleration and maybe more science gear possible.
Late 2040s. Wow, that's a long-term commitment. But I guess the argument is it's still closer than Alpha Centauri's planets, right? An actual interstellar object within reach, sort of.
That's the perspective, yeah. It's an interstellar target, but not requiring an interstellar journey from scratch. Still, huge undertaking. But maybe we don't need to chase this specific one. What about finding the next one?
Are detection capabilities getting better?
Oh yeah, significantly. The Vera C. Rubin Observatory, coming online very soon, is expected to be a game changer. It should spot Oumuamua-like objects much earlier, maybe 3 months before closest approach, and could find potentially dozens per year.
Dozens a year. Okay, that changes things.
And then there's ESA's Comet Interceptor mission, launching later this decade. It's designed to basically park in space and wait.
Wait for what?
Wait for a suitable target, a pristine comet visiting the inner solar system for the first time, or an interstellar object like Oumuamua to fly past relatively close. Then it zips over for a detailed flyby. First mission ever launched without knowing its final target.
That's ambitious. So we're getting much better at spotting these things. But none of that helps us with the original mystery guest, Oumuamua, which is already long gone.
Correct. That data is lost to us unless we chase it.
Which brings us back to that fundamental question. Do we pour massive resources into an incredibly difficult chase mission for this one enigmatic object? Or do we focus on finding and studying the many others that Vera Rubin and other surveys are likely to discover soon?
It's the big debate. Is the unique puzzle of 1I 2017 U1 worth the tremendous cost and effort of Project Lyra? Or is it scientifically more productive to wait, gather data, on potentially dozens of similar, easier-to-reach objects in the coming years?
The known mystery versus the potential of future discoveries.
Exactly. Technical feasibility versus economic reality and scientific priorities. Plus, that inherent human curiosity about the first one we saw.
A tough call. So wrapping up our deep dive on Oumuamua, the main lingering questions are still Its origin, that weird shape, and definitely that unexplained acceleration.
Yep, those are the big three. And the explanations boil down to, well, natural but weird, like the dark comet releasing hidden hydrogen.
Or maybe the less likely hydrogen iceberg.
Right, versus the much more extraordinary and debated idea of alien technology.
And without more data, we just don't know. It really highlights how science works, doesn't it? You find something weird, you propose ideas, you argue, you look for more evidence.
Absolutely. Oumuamua remains an unsolved case file, in a way.
But maybe the final thought is this. Even if we never know for sure about Oumuamua itself, the fact that we're now finding other objects right here in our solar system that seem to have similar unexplained accelerations.
Yeah, that's maybe the most profound takeaway. It suggests there might be physics or processes happening with seemingly normal asteroids and comets that we just don't understand yet.
It forces us to look again at things we thought were ordinary, doesn't it? Makes you wonder what other cosmic assumptions might need a rethink.
Definitely makes you wonder. The universe still has plenty of surprises up its sleeve, it seems.